Hi and welcome to my shop. Hey, today's the 2nd day of December. Holy smokes. Time is marching by. So I'm going to start off today by testing the remaining 4 untested tubes in this radio. And already, holy smokes, my cat is already after me. Okay, so there's 2 1T4 tubes in here, so we're going to start off with that. I think this is one of them right here. Let's see. So these tubes are designed to work in battery operated radios, 1T4. The filament voltage is 1.5. It matches a battery voltage, makes it easy to supply the filament voltage. And they have no cathodes, so they're basically use directly heated cathode. I guess that's not quite the way to put it. The heater is the cathode. So that's the tube checker we're going to be using there. I've already got it set up for a 1T4, so it's just a matter of double checking now. So very important, filament 1.5 volts. Can't afford to make a mistake there. Okay, 2 on the signal, 0 bias, 7, hard for me to see it, 7340K, 7340K, 5600. Sensitivity, meter sensitivity 40, plate is C. F means it's going to show a short on one of these short test settings. And then K1, K2, sort of suggesting that there's two cathodes. Okay, so we'll plug them in. Switch on. Like I said before, these tubes are pretty much leap into action. I certainly don't see the filament in there, but maybe you can't with these tubes. Short. There's the F warning. Letter F. And just making sure. So 580, so it only has to come up that far on the scale. Oh. That's pretty lame, in fact. Let's try that again. So it's supposed to come up to 580, it's coming up to 100. Why is it jumping around there? Okay, maybe it's just tube contact. Boy. And stuff like this, I wonder, okay, is this my tester or what? One way or another, we're getting our way up to 580 here, very slowly. So it's not dead. I think it's just contact in here. Yeah, it's not a dead tube. Okay, the main thing we're looking for, though, you know, with these tubes is an open filament. This certainly isn't the tube with an open filament. Okay, now I'll get the next 1T4 out of here. Let me put this one back. So I'm anticipating one of these tubes is going to have an open filament, because none of them were lighting. Yes, Peanut, I hear you. I hear you out there. That's a 1U5. Let's try this one. This is the made for Westinghouse. Uh-oh. It doesn't say anywhere on it what it is. Oh no. Well, we can guess this is a 1T4. Maybe this is the burned out one anyway. Maybe they put the wrong tube in. Maybe this is the wrong tube. Maybe this is not a 1T4. What's the other 1T4 look like? Let's compare them here. Don't get them mixed up. This is the good one. Not much to see inside to compare. You see remnants of the old label. Now they look the same. So, I mean, our best assumption is it's a 1T4. Put the other one back in just so I don't mess up. Okay, 1T4. So this is all set to go. You know what? I never did the K1, K2 thing with the last tube. Whoops. I missed something. Let's go back. Put the first tube back in. Once again, I came up and then sinking down, which is not a very good sign. K2. Yeah, no dramatic difference there. Okay. Just putting it back in the radio again. Okay. Let's go with this one now. Okay, ready on the test here. Well, so this one's well, it's showing a little low too. I mean, this could be the tube tester that's low. It's just a little. I mean, it should be above this line. It's more than a little low. So that's 2 weak 1T4s. They're testing the same on here. So, but again, filament is good. Filament is good. Put this guy back in. I don't have a lot of replacements for this type of tube. This is a 1U5, I believe. 1U5. Okay, so we'll do this one next. One of these guys is not going to work. 1U5. 1U5. 2 0 73400 73400 73400 5600 5600 is already up there. 41C 41C F still showing. So probably that's pin 1, and probably pin 1 is a shield of some sort or something like that. That's why it's showing up as a short. Oh my gosh. What is going on? Well, what's the problem? We already did stuff today. We were doing stuff together. Now today it's not snowing. Instead, it's raining. It's going to be about 5 degrees out. We've had the same snow on the ground now for maybe 3 weeks, and it's probably going to go away. Okay. You like that idea, do you? Yeah, I know. Cats, of course, love going outside all summer long, and then in the winter, it's this. Okay, here we go. I just have to kind of ignore them as much as I don't like ignoring my cat. Cats are very polite animals, and they expect people to be polite too. Okay, are we ready for this one? So this guy's same sort of reading, and it's supposed to be same 410. This should read 410. So this is also reading low. So you know, all the tubes are reading low. I'm pretty sure it's more indicative of my tube tester than anything. Okay, out with that tube. This one goes back in. That leaves only one more, so this must be the dead tube. This. Oh no, I just pulled out the wrong one though. This one. This must be this guy. See, at the last minute he's trying to hide. 1R5. There we go. R5. One 1.5207345K 7345K 5600 48 and C 48 and C. Oh, so we got F, K1, K2, it says whole tube. Okay, everything's ready to go. Plug them in. Check for shorts. There was pin number 1. Okay, here we go. GM test. Oh my gosh, I need a tube with an open filament. How can this be? This can't be. 556. So 910. So you see, this one's like right on the money actually. Look, it's sinking too. Generally suggests the tube is worn out. Generally. Okay, that's the story on that one. What am I going to do now? I didn't find my blowed up tube, but I want a blowed up tube. I want a faulty tube. So what's possible here? It could just be a 2-pin contact was bad, and just by pulling them out and sticking them back in like I'm doing, I may have fixed things. You may want to believe that. Put your money down on that one. So we're gonna have to power them up again, I guess, and try to sort out the action here. Now it was 8 watts of energy consumption yesterday, which I kind of assumed was all the tubes. But that 8 watts must have been just the rectifier tube here. And you know, it doesn't sound terribly unrealistic for the wattage of the tube. There might have been another watt going away somewhere in here. So we can watch the wattage and see if it's any different when we operate it this time around. Okay, everything should be safe and in order, just as I left it. Switch is off. Okay, let me just put the meters in view here. A little hard to see in the camera today, but they are what they are. I feel very hesitant. Dim light. 8 watts. 8 watts. 6 watts. Sometimes when you have tube filaments in series, there'll be a series resistor to compensate for the fact that the filament voltages don't add to the line voltage. But these aren't like that. These are in series, aren't they? These are in series. If I've understood this right, which I probably haven't, maybe getting their feed right from here. Yeah, I have to sit and study this for a while. So we look at this tube, and its heater's quite clear, just an in and out. Comes along, quite clear, in and out. In and out. And okay, that last part didn't quite work out. Yeah, it just seemed to be in series. Not this tube, of course. So who's the bad guy? So what I can do is take a voltmeter and start plugging along the terminals of these tubes, looking for where there's voltage and where there's not. Another way is, if I could figure out where the power is coming from to get to the tube filaments, I could look for a resistor that's open. And I could also even just check this right down here too. Right on one of the capacitors that I just installed. Could look for voltage on all the capacitors and make sure the power supply is supplying power. Okay, so to do that, I gotta flip the radio over and a couple other things here. Because it definitely did not come on. Just leave it like that. We're not too interested in tuning it or anything of that sort just yet. Anyway, checking these, good. Okay, so we want to try to read the voltage. Let's use this guy here. We want to read it to the negative bus. This hooked up right onto there. I guess you can hear that in the video as I'm doing that connection, because I can hear it coming out of a radio I've got going in here with the volume down. I can hear a little crackle. So there's a lot of stuff that shows up on the videos that I do not hear in the shop, and some of it is quite interesting and quite it's something worth looking into a little further, but because I don't hear it while I'm working, I never pay attention to it. You hear it all the time. So if I want to test the 4 capacitors, it's pretty easy. I get that terminal, this terminal, this terminal, and the last one is this terminal. Okay, good, should be easy to do. So you can keep an eye on this meter. This is set to the 150 volt scale, full scale. I guess I got to turn the radio on to make this work. Radio's on. As far as I know, only the rectifier tube is lit up on top. Okay, first one, I'm not sure I can do this in order. Pin 6 of the rectifier tube should show 90 volts. Pin 6 of the rectifier tube should show 90 volts. Oh my gosh. Counting the pins is a little bit tricky here. Oh, wow. I'm not sure where pin 1 starts on there. Let's see if I can see some numbers. There's 2. Number 2. That's number 1. 1, 2. I'm looking at 2 there. So we were looking at pin... oh, I'm down. What am I doing? Back here. Slow down. 6. Look for pin 6. Oh, wow, I better drink some more coffee here. Holy smokes. Pin 6. 1, 2, 3, 4, 5. This would be 6. Watching the meter here. Nothing there. What here? How about anywhere in here? How about anywhere? Anywhere. Any positive voltage. Should be something here. There's something there. Okay. I was just getting the wrong pin on that too. So looking at this, we're looking at 75 volts on, and I can't tell you which one of these it is offhand. Probably this point here. Since I've moved down along the resistor, I should get each of these voltages. So let's try again. I'm not moving along the resistor. Let's go along the resistor here. Here we go. Okay, so that's 50 volts. Right to the end here. That's the end. 20 volts. 20 volts right at the end. And moving up. 50 volts. Moving up. That would be 80, that'd be 87. And then the last tab should be the almost 90. So these are all correct. These are all correct. The last one, where it says 8.5 volts. Let's go back to the last one. And the actual voltage is, come on meter, 60. 6 rather. 6. So, and that's a curious voltage. 8.5, 6. What is this thing doing? This has got to be either a bias voltage, which does make sense because it's positive, so it can't be a bias voltage. This is probably the filament. Would they really do that? Well, let's pick a filament. Pick a filament. Pick any filament. Let's pick this one. Just follow the wires back into the power supply. Oh. Right there to the 8.5. Right to it. In fact, these three switched terminals here, you could think of them as selecting either the power supply or the batteries. So, see if this were flipped, it would be down here and picking up 9 volts from batteries, which batteries wear out. So 9 becomes 8.5 becomes 8. So the intended target voltage is 8.5. So this is the filament voltage, and I'm reading 6. 6, and there's no current being pulled through it. So this goes along, comes up. This is a center tapped filament. Well, just ignore the center tap for a minute. It goes in 7, out 2, and then from 2 we're starting the series thing. There we go, up through. Ignore all these other wire connections. Up and through, back along here, back, along here. That's where I get a little bit confused. Up and through, and out. Somewhere, somehow. Okay, so I didn't quite get that 100%, but that's okay. It just shows they're all in series. Did I pass a resistor anywhere in there? The only one is this one, 680. Now, if this resistor were open, I wouldn't stop current from flowing. Okay, one more time. We're reading 6 volts here, okay. 6 volts being delivered this way. It's also being delivered up this way. Doesn't make sense, you know that? Am I reading this right? So, yeah, 8 volts being fired up. To the screens. Okay. Yeah, I'm trying to look for, you know, where should I look to find a problem here? This really some kind of, if there was a short that was keeping the current from reaching the tubes, I think we would see that on the watt meter. The watt meter is still saying 8 watts. It's possible these tubes are on and I don't realize it. I think they're not when they are, and the reason the radio's not making any sound is something else. Just because I look at them doesn't guarantee you can see the filaments. So let's look for a voltage across one of the tube filaments. Okay, so this tube is pretty much in the clear here. I think this is the first 1T4. I think it's this tube here. So if we want to look at the filaments, we'd look at pin 1 or pin 7. Just either side of the gap, pin 1 or pin 7. And that's easy to find, I think. Okay, so here's pin 1. With my arm in front of the meter. Pin 1. There's pin 1. That's almost the whole 6 volts. Now at pin 7, almost the whole thing again. So this is coming up to, well, 5.6 from where I'm standing. Just a hair lower. I mean, not enough. So I'm finding the same voltage on either terminal, which has to mean there's just no current flowing through the circuit. The voltage is just sitting there. So we're just going to have to work our way through these. I have to check each tube and see which one isn't getting any juice, and then we can track down where the problem is, I think. So we just pick another one. Looks like 7 and 1 again. I guess that's probably the standard here, 7 and 1. Okay, so 7 and 1 on all these tubes. Next tube, please. Next tube, 7 and 1. Here, these are easy to get at. One's not connected to anything. So what tube did I just pick there? That's not a good tube. One and 7. Oh, so you could hook up to 5 or 1 and get the job done. So there's an internal connection in the tube. So I should still see something on 1. So here we go. This is pin 7. This is pin 1. And you can see it there. Another tube. There's one under here, but it's really hard to. I can't get at the pins here. Okay, I can get at pin 1. Here's pin 1. Hey, nothing happening. Pin 7. Must be right up in here. Nothing on either one. So you think that you could read the voltage until you cross the break. Once you cross the break, you won't find anything anymore. So now, fortunately, this schematic doesn't have it, but a lot of times they have a detail of how these tube heaters are connected because they're complicated. There's an order to them. It's not just the geographic layout in the radio. There's an order to which filament connects to which, because you want certain you don't want certain things to happen with certain sensitive tubes, so there's an arrangement here that's been engineered out, but it's not displayed down here. It's not written anywhere, so I got to kind of follow all these wires. So I think what I'm going to do is to save me a little bit of headaches, I'm going to color this up, and we'll carry on with a colored up version of this schematic. Okay, well, I went away, got out my colored pencils and colored this up. Quite an education in doing that. So let me show you a couple things that I found, a couple of questions that I have. So when you look in the power supply here, you see these 4 capacitors. You tend to think they're somehow all related. Well, they're related in that they're in one can in the radio, but otherwise these 2 are really quite separate from these 2. So, and there's something funny going on here I'm going to explain in a minute, but if you look at this one, and these are hops, hop, 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 all the way to here. So even though they show it down here like it's part of the power supply, and you'll tend to get that in your head when you first look at this, it's really not. It's really up here doing something with the heater line. This one's the same deal. Okay, it's actually a capacitor hooked up to quiet down this line here. There's B plus, something like that. Question is, what's going on right here? Now, earlier on I had a discussion about how nice this schematic was, and I started talking about the use of dots. I got pretty excited about this dot here. You know what I've learned later from coloring this up is that they put a dot here and my eye goes there and sees it, and there's no question the dot means a connection. Can there be a question about that? But right over here, just a fraction away, is another cross. Just an inch away. Are those connected? They're probably not connected. This one here, almost certainly not connected, because look, it's on the red B plus line. You'd just be looping around and shorting back to here. It doesn't make sense. So what's happening is the drafter has left out some hops. This is a hop. There's no way this red line's connected to the green one here. It's just not going to happen. So that is not a connection. This is not a connection. And it's not consistent, unfortunately. So, you know, wow. I know how tough it is to make these drawings up. I've done it myself from looking at circuitry, and it is really tough to do. So the idea that there's errors in here, or things have been drawn using a technique which actually is misleading at a glance, which is quite often the case. Another thing I noticed is earlier I had found this guy. This is a coil and capacitor unit, and there's another one here with this unconnected end hanging over, which is kind of curious. Well, there's another one I missed. There's one up here. Another one. 2 inductors and a capacitor inside something, inside some shielding. So now in terms of what we're really after is heaters being in series. If you notice, I've got some green lines here drawn. This is supposed to cover, the green line is supposed to cover the circuit that's supplying the heaters. Oops, I just slacked off here. I didn't draw the green in here. So you can kind of see at a glance, coming out of here, going up in here, come along here, going up in here. You can see pretty quickly how they're in series. Or can you? This comes back to the supply, and this other side, nope, just goes to a capacitor. So that's not a supply line. So what I've noticed since I've come in here and started talking about it on the video here is I never drew the heater supply to here. There's a lot of weird things going on in this radio, I gotta tell you. So here's one of them here. So if we follow this heater line, it's up on pin 7, out on pin 1, capacitor. So my thinking is these are all fed with DC coming from down here. There's no reason to think any electricity is going to get through this capacitor. So that's an open circuit. So what's this? Is this a connection? A connection to what? If this is connected, then the heater power comes down here, and it's got to go somewhere in this line. So where can it go? You know, maybe there's a ground in here I didn't see. Hop over. Oh, look, it comes all the way back to the other heater here. And the big capacitor there. boy, oh boy. Okay, so if we say that's the deal, then it comes up, comes down, heads out this away. It's up here. See, this big capacitor could mean that this wire, signal-wise, is the same as this one. Oh, it's all heater stuff. 25. Okay, no clue what's going on with that. Carry on. Pass this tube. Okay, so now we get to here. Up through the heater, down. Can't go here. Gotta go here. Here, all the way down, down. Hop, 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 hopping all those. Hop, through there, hop, hop. Way over to, oh my gosh, look at this now. So this is the, oh my gosh. Didn't I study this schematic already? So this is the connection to the chassis through a sort of mid-size resistor and a fair-size capacitor in this case, 0.1. So the draftsman has located this here. Well, why he's placed it here on the drawing, I'm not sure, because he had lots of opportunity to put it in other places. And he couldn't fit it in here. We ended up sticking it all the way down here. That's really hard on someone like me trying to understand the schematic. So that's all that is. That's just the chassis connection made at this point. So we still got to figure out where the power is going through the heater here. It's coming out. The only option now, if it's a 120 ohm resistor this way to the chassis. So let's go this way. It's another 120,000 ohm resistor. So I don't know, is there something wrong? Something is wrong in here, I think. They drew the schematic wrong and now the radio doesn't work. Son of a gun. If I fix the schematic, the radio will start working again. So I can't sort this out. You know, maybe like a lot of these things I come back later and look at them and then I can sort it out. But at this point, well, let's assume somehow 8 volts pushes current through 120,000 ohm resistor sufficient to heat these heaters. I can't see how that can happen, but here we go. Through here, down here, we get to here. Well, look here. It's one way to nowhere and the other way to nowhere either. So this can't be any... So how does the heater current get out of here? It's got to come down through here. But then, you know, it's another 120,000 ohm resistor and it's tied to the chassis. See, there's no... Ooh, I almost said there's no chassis return here. There's something here, but that's through a capacitor. What's this? Oh, so okay, so maybe when you have the switch this way, which is AC powered from the rectifier, you engage some other capacitor, and when you flip the switch to battery, this one, battery, you engage this capacitor. I'm clueless. I don't. There's another. Yeah. My head is coming off. So again, what am I doing this for? Trying to come up with a rational way to explain why I found no voltage at this tube. Oh my gosh! It has to be this tube, doesn't it? It has to be this one with the wonky schematic. Okay, so let's do it again. So I think I know how the power got here. It came along this wire. .7 megohms. So this wire at this point is acting like it's the bottom of the volume control, sort of. Okay, stay on focus, Jim. Stay focused. So the current feeding the heater is flowing in this wire. And, assuming this is a connection. Up to here. Yeah. So it picks it up here, brings it down, flows it Close it this way, that way, this way. So now we're into this heater. Now we're coming out the other side. You can see the electricity trying to make it. It can't go here. Wouldn't want to go here. You can't anyway. Down here, hop, 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 under, 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 hop, hop. So you really can't be going through a 120,000 ohm resistor. It just can't be the case to the chassis. So it must be going on another route. The other route, the only other route is this route. This another 120,000 ohm resistor. Hop. Hops right into this. So that's why there's no voltage here. This tube's not hooked up. That's the way they built the radio, with this tube, no heater circuit. Oh my gosh, what is going on here? Oh, this is like the worst of all worlds. I gotta get another schematic. Maybe Supreme's not so supreme in the end. They moved this up. Yeah, I think I could stare at this all day and it's just not going to resolve into anything different than it is now. Or are you yelling at me saying, Jim, 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 look, 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 look. I've looked, I've looked. Well, let's make some assumptions then. So it's pretty clear that it's coming down this way, according to, one of the assumptions I'm making is that anything on this schematic is correct. Around here, around there, around there. Now from here, where would it want to go? So when it gets to here, it's been through every tube. Like if we start here, that tube, that tube, that tube, that tube, that tube. So it gets them all in a funny order. So this should be returning. This should be returning to here basically. Okay, so where's this go? It's going to is that right? Yeah, it's coming from here. It's going to want to return to here. So here, 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 here. Hop. Connect it back here. When this is closed, this is the on-off switch. So that's the power coming in right from the outlet. So this is showing me now, it's the first time I've really seen this, that one side of the outlet power is connected right in to here. This then connects here. Hot resistor. Everything's got to get through this resistor? Wait a minute, maybe, I don't know, does it come up the resistor and split part of it going this way, part of it going this way? Does that make any sense? So the supply comes out of here, comes up, goes in here. We never really did examine this center tap thing deal here, so let's do that now. Some of it's going to go down the center tap. That's a hop. That's a fairly big resistor. And back to the AC line. Not to worry much about this connection this way. Just orienting the grounding of the radio relative to the hydro system. I think that's how we can look at that. So this so what's going on here? Good question. Let's answer that question. So there's how the power gets to the heater. It comes down here, comes all the way through here, comes up this way through the heater and back out the line. So radio, you know, this is not going well. So far I've only seen one item that can go open in this whole circuit, and it's this 680 resistor. Surely a 680 ohm resistor on a center tap, and this is not, it's not defining everything, is it? Maybe it is. Maybe this is the balance dropper to, doesn't make sense. So I got 8.5 volts. You'd think they'd construct this voltage to match the demands of the tubes. So we got 1, 2, 3, 4, yeah, 5, good counting, Jim, 5 tubes, each one doing 1.5 volts, 7.5 volts, supplying 8.5 here. Did I do that right? 5 tubes, 7.5 volts. So. So the kind of resistance you would find, I don't know the current flow in here. It could be, I don't know, it could be 100 milliamps, a couple hundred milliamps through the heater here. I'm lost. I'm totally lost. I don't know where to go here. Got a problem with the diagram here. Can't logically analyze this thing. I'm not sure what's going on with the center tap yet. Don't know much of anything here. Let's see if we can find the 680 ohm resistor and just shooting in the dark and see if we can find this and see what condition it's in. So chances are it's right attached to pin 8 of the 3Q5. Boy, this is not going well. It's not a happy day in my shop here. And really, what would have made it a happy day was an open circuit filament. Hey, now what if on the 3Q5 the tube test was invalid? The 3Q5, was the tube test done with 3 volts or was it done with 1.5 volts? Can anybody remember? The reason is, under certain circumstances, you can have one of these two filaments open and the tube tester would still succeed in testing the tube. Hey, oh, yeah, I'm pointing back here. Still back here, stuck on the schematic, even though you moved ahead to the radio. 3Q5. Hey, let's just get the ohm meter on it and see what's going on. Stop. Everything's safe? Yeah. We're safe here. Okay, I need to dig out the 3Q5. I hope it's good because I don't think I got a 3. I haven't got a tube like this, I don't think. 3Q5. Okay, so according to the schematic here, yeah, hey, back on the schematic again. You can even come down from the sky here. My meter. So if we do 2 to 7, we should see the whole resistance of both halves. And that's where I suspect we're going to see an open. 2, here's pin 2. Pin 2. Pin 7. Well, it's not open. Another exciting 20 ohms. and the other center tap is 8. Let's keep going here. So we go to 8. And then, of course, this has to work when we go back to 2. Well, that was a great, exciting moment, but tain't the case. Tain't the case. Okay. I think maybe I should stop and just ponder the situation here and maybe go watch TV for a while. You know, it's at frustrating moments like this that sometimes I think, you know, a little guitar would go really good right now. So I happen to have a little guitar. So, isn't that nice? Look at that, eh? My son bought me this years ago. Gibson acoustic. It's really nicely done. Okay, that's great. That helps out. Fantastic. Oh, now I'm back to this. Okay, I'm going to study up here. I'm going to figure something out. I got to figure something out.